Right, so here we are, section 7.6, take 2. My other video totally crashed on me. So here I am on Friday taking this video. Sorry if you tried to watch the video last night. I apologize on that. Can't do much about it. Hey, so we are solving equations. It's a big section, 7.6, and I think we're going to take 2 days. We'll practice on Monday and Tuesday. We are solving both exponential and log equations. So we've got quite a few examples. The first ones are all going to be exponential equations. Basically, the variable x will be an exponent. And for log equations, the variable x will be embedded in a log function. Let's get some basis for how we will solve an exponential equation. So again, this is just for exponential equations. I had b to the x equal to b to the y. If this equation is truly equal, then x and y have to be equal. There's really no choice to them, to satisfy this equation. So here's a super, straightforward example, but it's the basis for what we'll do more difficult problems. If I had 5 raised to the x is equal to 5 raised to the 4, notice we have the same base number 5. There's really nothing else that will make this equation equal except to set x equal to 4. Does that make sense? So we basically grab the exponents and deal with them as in their own equation. However, be careful you don't cross off the 5s, you don't cancel 5s. You're just having to say, look, if this equation is going to be equal, we have no choice but to set x equal to 4. So let's see how that works in a harder equation. So here, first identify this is an exponential equation because the variable x is an exponent. And so right now, can I just take the exponents and set them equal to each other? No, because I don't have the same base, right? So 64 and 16 are different numbers. Hopefully, though, you're looking at both of those and saying, whoa, they share a common base of 4. So here, this is kind of the technique. We would set 64 equal to 4 to the third. That's the same value. So again, just, to be a little bit flip, let's say the next time you want $64 from your dad, say, hey, Dad, can I get 4 to the third dollars? And he'll think you're really cool. And you'll be asking for the same amount of money, right? 64 and 4 to the third are equal in value. So you haven't changed the equation, but you certainly have changed the look of the equation. And now we need to deal with dropping the parentheses. So 4 raised to the power 3 raised to the power x, your exponent rules tell you that you need to multiply. So this would become 4 raised to the 3x. And notice this 2 multiplies to both the x and the 1. So really important. I like drawing these arrows. I know that it doesn't have an arrowhead on it. There you go. But you want to distribute that exponent 2 into both exponents x plus 1. And you get this. And now, finally, we get to say, look, the only way this equation is truly equal is if the exponent pieces, 3x, and this piece, 2x plus 2, are the same, right? That's the only way this would truly be an equal equation. And we call that the property of equality. Big deal. But we set the exponents. Again, don't say, oh, let's cancel the 4s. We don't do that. We just set the exponents equal, and then you're into a super easy equation, right? It's algebra 1, there's your solution. You should check your solution, but in this case, I'm going to be confident in my algebra. So, what happens now? So here, again, this is an exponential equation. X is that is an exponent, so it's an exponential equation. You can't use the technique we just used in example 1 because 6 and 27, there's no way to write those as the same base. 6 squared is 36, so I don't know what 6 to what power. So we have to switch and use our logs, right? So they do a nice, I'm a little cautious to get into how this works, but we've done similar problems, but not quite that much to take the log base 6 of both sides. I kind of want to skip this if that's all right with you. I'd rather take this equation and switch forms, right? So if I switch to log form, I say log base 6 of 27 is equal to x. Again, to me, this problem here it's really the whole point of this chapter is to be able to solve this exponential equation. I mean, there's more to it, but I like it that way. We can't do this on our calculator, so we use the change of base formula that we learned yesterday. and then in the calculator, and you do really need your calculator to solve this, we would get that answer. And we like this answer, right? We would expect, again, 6 raised to the power 1 is 6, 6 raised to the power 2 is 36. So I'd expect my answer somewhere between 1 and 2. And because 27 is closer to 36, I'd expect this 1.8, higher than 1.5. Great problem, great problem. Here we go, and we're building it up. First of all, E we're getting more comfortable with. E is that natural base, 2.7. And this is an exponential equation. You should kind of look at this like, why, I can clean this up a bit, right? I could subtract the 8 before I worry about dealing with the logs or switching forms or any of my other moves. I can also divide by 6, right? Again, so these first 2 steps really help us. They clean up the equation. They're easy to do. And you got to really look for those. Now you're basically stuck, right? You can't get this 0.25 off the x. It's embedded within the exponential piece of the e. So we switch forms. And again, the book has this line here. I'm going to scratch this off again. I think it's just fine if we say, look, we're going to take this and switch to log form. Log base e, which is ln, of 2 is equal to the exponent. And you would need your calculator here, right? In your calculator, you would type ln of 2, and then to solve for x, we'd have to divide both sides, right? Divide both sides, so this would be divided by 0.25, and that would be your answer. Great problem. Again, really, you should, look at this problem. Pretty exceptional. Whoa, I didn't mean to cross that off. Really hard problem, and we need to practice. So like I said, we'll probably spend 2 days practicing these. Could you give these 4 a go? So again, let's, maybe we should start by just, what would our strategies here be? All exponential equations, right? Here, because of the 3 and the 9, hopefully you recognize that they could be written as the common base. So I would urge you to take 9 and write it as 3 raised to some power. This guy's going to be harder, right? Because I can't write 5 as to some power and get 72. Here I think you need to switch to log form and do change of base. This guy would be the same, but I need to first, clean up the equation. So spend a few minutes here, and when you're ready to see the answers, go ahead and hit play. And here you have the answers. Again, the answers, of course, from the book are in red. Problem 1, I wrote 9 as 3 squared, so it's a little messy, but I wanted to highlight with the red, right? 3 squared. And then you'd have to distribute. So 2 times 2x would give you 4x. I would set 4x equal to the exponent here, 7x minus 3. And then you know how to solve that. Notice on this problem, you can't set 72, to 5 raised to some power. So I switch to log form, right? I say x, the exponent is equal to log base 5 of 72, and then I change base, log 72, log 5, grab my calculator. Do I like my answer? I do, right? I know 5 to the power 1 is 5, 5 to the power 2 is 25, 5 to the power 3 is 125. So I'm expecting my answer to be between 2 and 3, and 2.6 sounds great. To do this problem, first thing I did was add 11, and then here I switched forms. So I said log base 8 of 11 is equal to the exponent. And now the calculator would I'd have to do change of base, but I could solve this with my calculator. I'd subtract 2, divide by 3, and I'd get my final answer. And problem 4, again, a little cleanup move. I would take the 2, subtract it from 5. I get 3, divide that by 3. This whole thing would go to 1. Then I'd switch forms, right? Log base e of 1 is equal to 0.5x. And this just goes to 0, and the problem's pretty much over. Nice job. So let's switch forms or switch this whole lecture to solving log equations. So it's kind of that same, property of equality that we did for exponents, now we do for log. So if I had log base b of x and log base b of y, the only way I can write an equal sign here, the only way is if x and y are equal. And so again, make sure you realize, like in this example, log base 3 of x and log base 3 of 8. We don't cancel logs, we don't cross off logs, we just say, look, the only way this is equal is if 8 if x is equal to 8, and then you're done. So let's get into some of our examples. So here we go again. Kind of looks intimidating, this equation, right? It's a log equation. But if you look carefully, they're log base 7 of something is equal to log base 7 of something. The only way this equation is going to be true is if the insides are equal, right? If this 6x minus 16 has to equal x minus, there's nothing else to this equation. So I just set them equal and solve using my Algebra 1 skills, and I'm done. So we do need to check, and check becomes a big deal with the log equations. Why? Well, we were told, or hopefully you remember from the graphs too, that you have a very restricted domain. For log functions, you can only plug in values that are positive. So anytime you take log of 0, it's not going to work. Anytime you take log of a negative number, it's not going to work. So here, don't just look at to see if this answer is positive, but see if when you plug it in, it's still positive. Look at this huge minus 16. And if the x is 1, right, which is a positive number, this wouldn't work. If x is 2, which is a positive number, you'd have 12 minus 16, which would come out negative. But when x is 3, 3 times 6, 18, that's big enough to overpower the negative 16. That would be positive. So this does work. But we're going to see another example where we'll solve and it won't work. Example 5. So here we are in a log, right? The variable x is embedded in this log equation, log function, excuse me. And I need to figure out how to solve. I can't notice that there's no log on the right side, right? So the last example I had log of something equal to log of something, and I just set the something's equal. But this example, there's no log on this side, so I can't do that. So what should I do? Hopefully here you're like, man, I'm stuck. I hate this. Well, switch forms, right? You've got, it's kind of a desperate move, but hey, switch forms. So again, I don't like the way the book does. It's not that I don't like it. I prefer you just to switch forms. 5 raised to the power 2 is equal to 3x minus 8. And then you're off and running, right? It's not that hard a problem anymore. So again, switching forms is so important in this section. The solution came out to be 11. Looking in here, 3 times 11, 33 minus 8, we're okay. Right? We could check even further, which the book does. But again, I'm looking to make sure that I'm not violating the domain restriction. And so here we go. This is the hardest problem in the last example I'll show you. So you're dealing with 2 logs on the left side, right? And you're adding those. So that, this should trigger you to think of the product property. And then notice there's no log on this side. So we do use the product property first, right? We can combine these 2 log functions by using the product property. So we multiply 5x and x minus 1. Don't forget to distribute here. And then we switch forms. So 10, and again, why is this base 10? It's a common log. 10 raised to the power 2 is 100, is equal to what's inside. And again, they're using this method, which is fine. I'm just not going to explain it to you. I'd rather you just switch forms. 10 raised to the power 2 is 100, is equal to whatever inside. And then you're into a quadratic equation. This guy cleans up quite nicely, right? Scale it down, factor it, and you've got 2 answers. And at this point, my goodness, you've done a lot of work. You're into some pretty heavy-duty log equations. Use your log property, switched forms. You've got 2 answers. You got to be excited and circle your answers and be done with it. Except for the fact that this -4 is going to be a big problem, right? And you can see right away if I plug -4 into this log function, I'm taking log of -20, which is not allowed, right? And if you plug it in, then you're done already. You don't even need to check anymore. You should check the 5 as well. This is 25, this is 4. It should be fine. And you can see here that when they plug in -4, they said the same thing. So this is not a solution. So when you're done with these problems, the only answer you can circle is this one. Even though you solve that guy, it's not a correct answer. It'd be great if you could try 4 problems here. We can kind of preview them here. You have ln. Again, ln is just log base e. And here, you should say, wow, what a simple equation. I can just set these insides equal and solve. Here you should switch forms, right? 3 raised to the power 3 is equal to the inside. Again, same with this guy. And then here you're going to use the product property. Combine these guys and switch forms. So hit pause when you're ready. Hit play. And I'll show you the answers and how I did them.